a few seconds for you to start recording. Hello. Okay. Okay, so we'll be doing tutorial 3 now. Okay, so I'll show you the first one. How do we do that for question 2? So at least you know, are you getting it right? Now, tutorial 3 or lecture 3 is on probability. Although you actually never need to really use probability substantially after this, maybe after next week, okay? But probability is the basis. You need to use it for your statistics. Okay, so that's why we need to learn some probability. Okay? It's because of statistics purposes. Okay? Probability is how often something will happen. Now, you want to learn probability. Probability is actually a totally separate science from statistics, although it's related, but it's totally different. Okay? So there's actually there are people who are called themselves the probabilists. Okay, so they study probabilities. Okay. Now, let's say if you look at this type of question, the most important is how do you draw the table. So I have a table shown on the screen already. How do you put the table in? The data in. So you have disease, D plus, no disease, and which is D minus, test positive, T plus, and test negative. So if you are given the percentage only, you can just assume it to be 100. Okay. So let's put the data in. Those probability of having a disease is 20%. So this is, let's say, 20, okay, out of 100, so 20%. Out of those having disease, 90% is positive. Okay, so 10% is tested negative. So this will be 18, and this will be 2. Okay, because it tells you. Okay, then what you have is how many people who do not have the disease. So you minus it off. Here will be 80, because you have to add up to 100. Okay. For those not having the disease, 5% is tested positive. So 5% of here is tested positive. Yeah, those who don't have a disease and tested positive is 4 of them. So you have 95% tested negative. So will be 76. Okay, so you add up here will be total of 22 positive and 78 in total. Okay, so you have to be able to fill up this table first. You can use percentage up to you as well. 5% positive. 5%. No, this is 5. And then this is 75. Okay. So 23. Let me just erase it. 4 or 5%. Okay. Okay, so this is 5%, and here will be, oh no, out of those not having disease, so it's 80, 5% of 80, so it's 4. Okay, because it's 5% of 80. Okay, so this will be 76. So here will be, made a mistake just now, 22 and 78. Okay. Yeah, because it says those not having a disease, it's not in total. All right. Then you are tested for what is the predictive value. That means those that have disease and is actually tested positive. That means what is the value of this test. Now, as you realize in our Singapore situation, last few days we have heard of this thing known as false positive test result. Okay, what is false positive test result? You know that I think there's 33 cases that there is COVID-19 is false positive. So which one is false positive? Can someone answer me? It is 18, 44, 2, or 76. So give it a try, Ben. Which one is the false positive number?
Is it 4?
False positive, correct. So this is false positive. Okay? That means it's tested positive, but you don't have a disease, so it's false positive. So opposite, this is actually called a false negative. You have the disease, but then you are tested negative. So these two are serious cases. Okay. There is a lot of measurements for it. You can go show you what is in wiki. So you have condition positive, predicted positive, this is true positive, this is a false positive or type 1 error. Then type 2 error, the true negative. You can use it to calculate a lot of different matrices. Okay, so all these are the different matrices that you can calculate. Okay. All right. So using this as a whole, how do we find the positive, the predictive value of a positive test? That means what is the probability that the person has the disease if it's tested positive? Okay. So this is person person having the disease given that the test is positive. So how you do it is, first you have to find out those that have the test and positive, divide by those that is positive, or those the test is positive. So how will you do that? Test and positive is actually 18, correct? The probability of having test and positive is 18 out of a total of 100. Divide by all those tested positive. Okay, all those tested positive will be 22 out of 100. Make sense so far? You end up with 0.82. Okay. So there is 82% chance that the person have the disease if he's tested positive, he or she is tested positive. All of you managed to get this right? You go and check your own answers. The most important is actually able to get to here. Then the next part is just press your calculator. Okay, so far, all right. Okay, no response means okay. Okay, now we do question 3. So now assuming that a rare disease is only 1%, so 1% of population, and you have found a reliable test. The probability of testing positive if the person has a disease is 99%. But there's a probability of testing negative if the disease is doesn't have the disease, also 99%. So it's quite a good reliability. Now, what we want is, what is the probability of the patient testing positive? What is the probability of the patient having the rare disease if he's tested positive? Okay. So let's say we fill up this table first, assuming that we have, let's say, 1,000. Okay, so if you do it for 100, you just scale it by 2 zeros. Okay, so let's try. So Daying, are you comfortable with giving us all the numbers to fill up this table?
So I didn't want to do it, so I didn't do it.
What?
I wasn't sure how to do it.
You're not sure how to do. Okay.
Yeah, I didn't do it.
Have you done question 2?
No, I only did question 4.
Okay, question 4.
Yeah.
So do you understand how I did question 2?
Yeah.
Okay. So I will not stress you up first. Look at the question 4. Question 3. After today, tomorrow and chance, you kind of have the whole answer and you redo it for yourself. Okay,
Okay.
Right.
Yeah.
Felicia? So, okay. Can you give me all the numbers now to fill up this table?
99% for test positive and disease.
Okay, so those tested positive and has the disease is 99.
Yeah.
Right? So 99. All right. Then how about without disease?
1%.
No, that's the negative is 1%, right? So
Yeah.
here will be 100.
Yeah.
Okay, because it's actually 100 because this number, right? Let me just scribble a little bit. This number is actually 1% of 10,000. Make sense? Okay, so how about this here? Positive and no disease.
The opposite. Like test positive, no disease is 1%.
Test negative and no disease. So let's say out of this 100, right? Let's give me this number first. This will be you minus it. So
no.
it will be 10,000. So this number will be these two numbers add up to 10,000 ma.
9,900.
Right, 9,900. Okay, so it's 99%. This is 99% of this number. So what is it?
9,801.
Right, 9,801. Okay, so now we have this 9,802. Okay, so do we know this number in the first place? Just minus it off,
Yeah.
which is
8.
this number. Just minus it off because this plus this has to give you 9,900.
99.
99, correct. So here will be 189. So you fill out the table already. Okay, so correct. Very good. Okay. So now, okay, let's have Ihan. Which one divide by which one?
Is it 99 divided by 10,000?
Correct. 99 divided by 10,000 first. 99 divided by 10,000. Then positive.
189 divided by 10,000.
189. No, this one 189. This is 198.
Oh, 198.
Yeah. 198 divided by 10,000. Correct. So you end up with 50%. So far, so good. Okay. So you can actually use just 100%, but now you end up with 99 in its proportion, its percentage. Okay, you can actually do that as well. Just that it's become a bit ridiculous because you end up with 0.01% testing positive. You can use a percentage, nothing wrong with that. Okay. So any idea, any question about these two questions? The main thing is able to fill up this table. Once you fill up this table, everything should look okay already.
Sir, may I ask regarding question 3 about the predictive value of a positive test. So is it correct to say that it is equal to P multiplied by D plus given T plus? Or
So predictive value is equals to having a disease and the test is positive, divide by the test is positive. Because the predictive value is really here what it essentially says, right? It is say what is the probability of having the disease. So this is D plus when the test is positive. So this is T plus. Okay. So that's how you read it. It's given that the test is positive. That's why it's conditional. It's conditioned on the test is positive.
So then later when we write out the conditional probability about equal P multiplied by D plus intersect T plus then divided by P multiplied by T plus so the D plus intersect T plus is actually referring to the no disease test positive over the total population or
Over total population. Over total population.
the
Yes.
10,000.
Correct. So it's actually this number divided by this number.
So it's not the one with no disease. It's the one with the disease.
Disease, right? It's both disease. That means it's because it has to be disease and positive. So it's 19. It's 99. But the probability is divided by total number of people. All right.
Yes, sir. Yes.
So this part is actually disease and that's positive. But in order to find the probability, you divide by total number of people. Okay.
Yes, sir. Thank you, sir.
Okay. All right. So let's go to question 4. Outbreak of psychosporosis among the attendees attending a wedding. Okay. So a 2x2 table shows this. You're ill. You ate the wedding cake. You're okay. Not eat the wedding cake and so on. Okay. So what you want to find out is use these words. Okay. Fill up these words. Food specific attack, proportion of patients who had ate the wedding cake, and overall attack rate of the persons ate the wedding cake. Okay, so the food, whether you ate the wedding cake, is actually the risk factor. The attack, whether you're well or not well, that is the attack. Okay. So the fraction of 54 divided by 79 is what? Grace?
It's overall attack rate amongst people who attended the wedding.
Okay. Can you repeat again?
Overall attack rate amongst people who attend the wedding.
Correct. So overall attack rate of people who attend the wedding. Okay. Correct. So the next one, 50 over 54. Okay, you can finish it again.
Is the proportion of patients who eat wedding cake.
Yes. Then the last one will be the food specific attack. Okay. So you should have these 3. All right. Now the one thing I will highlight to you about probability is this. If you find that you are going around in circles when you think about probability, please stop thinking. Okay. Go and take a 5 minutes rest and then forget everything and rethink again. Okay. Because it will make you crazy. You'll keep thinking about it. Okay, so D, what is the measurement? What is the name for the measurement for the data? Basically, the answer will be either relative risk or odds ratio. So, Tonara?
Relative risk.
Correct, relative risk. And what is the value for relative risk?
I don't know.
Don't know. Okay. So relative risk is correct. Okay. The person who ate the cake and fell ill divided by the person who fell ill and did not eat the cake. So it's actually 6.5. 1.3. So there is a high likelihood that by eating a cake you fall ill. Okay, so there's a good relation there. So it's relative risk. It's called risk ratio, but it's also known as a relative risk. Okay, so essentially it is this number divided by those who fall ill but did not eat the cake. So those who fall ill and did not eat a cake means that you're just a bit sway. Okay, let's fill up this contingency table again. For question 5, a study has been done to find out if smoking raises blood pressure. A group of 300 people, 133 are smokers or have experienced smoking, 75 with no high blood pressure, and so on and so forth. Okay, so you build a 2x2 contingency table first. Okay, so Hugh, why don't you give us all the numbers?
Okay, I tried to best of my ability. I couldn't really figure this out a bit, so sorry if I get some of the numbers wrong.
That doesn't matter. Okay, so let's try. What is the total smokers first?
Total smoker would be
Or rather, which? Okay, you just tell me which number is like to put in. Let's say for high blood pressure.
high blood smoking would be 133.
Yeah, 133, correct. No problem.
For smoking and no high blood would be 202.
Smoking and no high blood will be 202. Very good.
No smoking for high blood would be 167.
167, yes.
And no smoking and no high blood pressure will be 548.
548, yes, correct. Yeah, basically all these four numbers add up to 1050. Okay. Okay, so what measurement is useful? Which measurement is suitable? Relative risk or odds ratio?
I think odds ratio.
Yeah, odds ratio, correct. Okay, it's odds ratio because usually you have identified the disease first. That's why odds ratio tends to be a bit more convenient to use. Okay, and what is the odds ratio that you calculated?
Haven't gotten too far yet, so sorry.
Okay, calculate lah.
Okay. Uh, 2.16.
Yes, 2.16. Go on, huh? Yes, 2.16. Okay, so it's essentially 133 over 202 divided by 167 over 548. Okay, so it's 2.16. Okay, so can you calculate, assuming I give you this table, calculate what is the relative risk? Try to calculate relative risk. So this is 2.16. Okay. Okay, you try to calculate the relative risk.
Okay. Is it 1.7?
Yep, 1.7. Okay, so it's actually 133. The denominator is changed, is to 335. Okay, over 167 divided by 715. So you realize that if the relative risk is more than 1, the odds ratio will be larger than relative risk. Okay? If your relative risk is more than 1, your odds ratio will be larger than relative risk. Okay? Because the denominator is the one that changed. Make sense?
Yes.
Okay? All right. So in this case, it means that people who are smoking have about 2 times the risk of having high blood pressure. Yeah, people who are smoking have 2 times the risk of having high blood pressure. They are more likely to be smokers. That's what it's trying to say. Okay. You'll find that in a lot of research papers, they will calculate both relative risk and odds ratio, because relative risk and odds ratio seems to be like the boundary. Relative risk is a bit underestimating, odds ratio is a bit overestimating. So it's the boundary. Okay, so let's deal with our chickenpox. This one is not easy. Okay, so Tracy, see whether can you do it or not.
Under the vaccinated and have chickenpox is 18.
Yes, 18, correct.
Then no chickenpox and vaccinated is 193.
No vaccine, you say it's 193, right?
Yeah.
Now this is, okay, we'll settle that. Okay, continue. This is wrong, 193 is wrong, but doesn't matter.
And total is 211.
Okay, so this part is wrong already. How about chickenpox without vaccination?
3.
3, correct. Okay, then this one, no chickenpox, no vaccination.
4.
4. Okay, correct. This is 4. Okay, why this is wrong? Okay, this is wrong, because in order to test for vaccination, you can only use those that have no chickenpox in the first place. Okay, so you have to remove those that have no chickenpox to begin with. Otherwise, the vaccination doesn't work. You get chickenpox once, you don't get it again most of the time. So here, actually, the total should be 153 instead of 218. So you minus it off. Here should be 134. So it does. Why I say this is difficult, because you need to have a little bit of your immunology with you. It's assuming that those having chickenpox doesn't get it a second time. Okay, you can be so unlucky you have 2 times chickenpox as well. So this is 7. Okay. All right. So then the risk of developing chickenpox among vaccinated is 18. So you should is 11.8%. Okay, in this case, it means that even though, how many of you never had chickenpox before? Anyone? Any one of you don't have chickenpox? You can raise up your hands, or just say me. Okay, you anymore? So the rest have chickenpox before. Okay, then. Okay, so Benjamin, you raise up your hand means yes or no?
No chickenpox before.
No chickenpox. Okay. So Daniel also no chickenpox. Jia also no chickenpox. So, wow, so many people without chickenpox. Tracy also no chickenpox.
Yeah, don't have.
Don't have. Oh my goodness. How many people have chickenpox then? Okay, so you can drop down your hand. So a lot of classmates do not have chickenpox. Okay. Now it's troublesome to get vaccinated, but if you can, after this circuit breaker, please get yourself vaccinated. If you are willing to do that, it's just one injection. Okay, it certainly beats you having chickenpox in the class. Okay, so Jianing, you raised your hand, meaning?
I got chickenpox before.
Chickenpox before. Okay. Chickenpox is quite an interesting case because most of the time when you have chickenpox, you do not get it again. Most of the time, but later part in your life, you can develop shingles. So when you have chickenpox, the virus called varicella zoster is in your spinal cord all the time. Is your immune system able to suppress it? However, there is a, can't remember a percentage, maybe like 0.5% or 0.5% of the world population cannot produce enough antibodies against varicella zoster, which means that you can have chickenpox multiple times in your life. For those who haven't had chickenpox, especially for the guys, if you go army without chickenpox, you'll get vaccinated as well. So it's good to just go for vaccination. Okay. Now, the older you get chickenpox, the worse it becomes. Yeah, you have chickenpox when you are a child, maybe you just have a few pox. But you have chickenpox when you're 50 years old, it can kill you. Okay. So the probability of developing chickenpox among unvaccinated, it is about 43%. Means that the risk ratio or the relative risk is 0.75 or 0.275. Okay. What it really means is if you are vaccinated, you have a much lower chance of getting chickenpox. Vaccinated children are 25% likely to be developing chickenpox. That's what it means. So this gives you opposite sense. Okay. Well, vaccination is the exposure. The exposure actually causes less of the disease. Okay. So chickenpox is a disease. This vaccination is the exposure. Okay. So, and just now, who is the one that answered Tracy, right? So Tracy, if you have the wrong number, you should be substituting the wrong number in only. But the equation, the relative risk, you should get it. Makes sense, right? That means this part you should be able to get it. Tracy, is that right?
Yeah.
Okay,
Yeah.
good. Yeah. So once you substitute the correct number in, it's easier. Okay. So why not someone calculate what is the odds ratio? Okay, Maximus, why don't you help me calculate the odds ratio? Means 18 divided by this 1 by 2. This is 18,134. 3.
Is it 0.179?
Yep, 0.179. Now you realize that then it's opposite. If the relative risk is lower than 1. Okay. Originally, if it's more than 1, then odds ratio is more than relative risk, correct? If the relative risk is lower than 1, odds ratio is then less than relative risk. Okay. So this is just now what we determine is if relative risk is more than 1, odds ratio will always be larger than relative risk. Okay, so it's an inversion. Make sense? The reason why I tell you this too is because you have to know how to check your own answers, whether does your answer look strange or not. Okay, because it's very easy to get the wrong answer in, which I think is on this week's practical already. It's very easy to substitute the wrong number into your equation. So this is like a check for you. So far so good? Any problem?
No, sir.
Okay, so let's go down. Okay. So let's go through this. Okay. So the 2x2 contingency table is a not easy question as well. So the 2x2 contingency table. How many of you managed to get to here? Okay, so let's get someone. Let's go down the last of the list. Jianing, do you manage to get the table properly?
I don't know how to do.
You don't know how to do. Okay, so the problem with this is you have to read the question and try to figure out. Okay, so let's see. In a clinical trial, the new medicine performing is for treating diabetes patient. 150 of them. So 150 are what? Diabetes patient. Okay, 150 diabetes patient. That is why you have 150 diabetes patient treated with performing. Okay, while 150 is on placebo. So this is 150, this is 150. So this is where the 250 come from. Got it so far? Jianing?
Yeah.
Okay, so this is where the 250 come from. Then what you say is, you read this part. Okay, among the performing group, 20 died within 5 years. So among the performing group, 20 died within 5 years. So 20 died within 5 years is where 20 come from. So how many survive after 5 years? You just minus it off, you get 130. So far so good?
Yeah.
Okay. Okay, in comparison to 30 patients who died, so 30 here, you minus off, you get 120. That's it. So you have to kind of piece down each part of the story at one part at a time. So you end up here is 50, and here is 100 and so it's 250. All right. Okay.
Yeah.
So now, why not, Jia En, you calculate the relative risk, and Jia Ning, you calculate the odds ratio. Numbers is given to you already.
Sure, is the relative risk 0.615?
0.615, correct.
Yeah, okay.
Around there. Okay.
I don't know Wait, what?
Do you know? Odds ratio. Okay, relative risk, this is from 20 over 150 divided by 30 over 150. Actually, it's not 0.615, it's 0.67. Because it's actually 20 divided by 30, it's 2/3.
What?
What? Okay, let me go back. How do you calculate the relative risk? Okay. Relative risk is die during cardiac, so it's 20 divide by the total number because it's add up to is 150. All right. Then the whole thing divide by 30 over 150. So here is essentially you minus off is actually 20 over 30, which is 2/3. 2/3 is 0.67. Okay, so who is calculating relative risk? Do you type in the wrong thing or calculator or whatever? Jianing, where's your odds ratio? Jianing, what's your odds ratio? Or Jiaen, what's your odds ratio? I don't know who is who now. Hello, both of you there?
Yeah.
So your odds ratio or what, Jianing?
I think so.
You think so? Okay, then calculate. Okay, so give me the equation first for odds ratio. What divide by what?
Is it 20 divided by 30?
No, it cannot be 20 divided by 30. It's 20 divided by 130. Okay. Then the whole thing, the next one?
Then 30 divided 120.
Correct, 120. So what will be the answer?
Uh, 0.615.
Yeah, it's 0.615. Right. Okay, all right. So I think Jian just now you're giving me the odds ratio rather than relative risk. Okay. Okay, so let's look at question 8. Question 8 just asks you which one is the conventional contingency table. Is it table 1 or table 2?
Table one, sir.
All right, so Sean, this is table 1. What is the reason?
So this is because in table one, the data has been summarized such that the rows are representing the exposure status, which is also known as the treatment factors, and the columns, they are representing the outcome status, which is the disease status.
Correct. Yes. Okay. All right. Okay. So, okay, then we go to just now we have up to Maximus. Okay, so Jeremiah, is this what kind of study is this? Experimental or observational?
Is it experimental?
Yes. What makes it experimental?
Cause the subject didn't decide which
Yes, it's
treatment to get.
randomized. Okay, subject didn't decide. Okay, decide treatment, correct. So it's experimental. Okay. So okay, does pervestin reduce the risk or not? So okay, Daniel. So this you calculate the either the relative risk or the odds ratio.
I didn't calculate both.
So can we calculate either one relative risk or odds ratio?
No.
Daniel.
I haven't yet.
Okay, so just calculate one of them. Okay, take table one and calculate either the relative risk or odds ratio, up to you.
Relative risk
Okay.
is
The relative risk is
0.700.
0.700. Yep, about there, 0.700. Okay, so in this case, does the treatment or the pervastatin, does it actually reduce the risk or not?
Yes.
Yeah, it reduces the risk, correct? Okay, it reduces the risk. Okay. 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 Now, it, it, it has been shown that we are 95% confidence that the relative risk is between 0.58, about 0.58 to 0.84. Can we conclude that pervastatin is effective? So let's try Rajini. Is it effective? You have not got this concept of 95% confidence yet, but is it effective based on the numbers? Based on the relative risk. Oops, what did I do? Of this, between this and this. So Ranjini, is it effective?
I'm not sure.
Okay, just if you're not sure, just make an intuitive guess, yes or no. It's just 50% each.
Yes.
Yes, okay, it's effective because if you look at the table, right, those taking pervastin has a lower rate of, okay, you see these two numbers are sort of nearly the same, right? 3302 and 32993. It's almost the same, but you can see that the death rate is actually much lower when you take the medication. Makes sense, right? Between 147 and 248. So there's actually a reduction in risk from myocardial infarction or coronary heart disease. So taking the pervastatin is actually helpful. Make sense?
Yeah.
Okay. So that's how you can interpret your results. A relative risk and odds ratio is actually a ratio. Okay. Yeah, because the range is less than 1. Okay. So use of odds ratio is also possible because it's a cohort study. Okay. So this part is easy. So you have to know how to interpret the relative risk and odds ratio. Okay. What you also need to do is quickly able to decipher, let's say for this question, right? Quickly able to decipher from the text itself into the table. Okay, otherwise you'll spend a lot of time doing that for your online assessment and so on. Okay, that's all for this tutorial. Any problems?
Chair, can I explain question 1E?
1E, okay, let's see, 1E, 1E, okay, 1E, this one. Okay, let's see. Hold on, okay, so 1E, is it true or false?
I don't know.
Make a guess lah.
No, like I don't understand what the question is talking about.
If the intervention increases the risk, increases the chance of event. Okay, I rewrite it in another words. It means this. Okay, or intervention means for exposure that increases the chance of event. That's what it means. Okay. So for exposure that increases the chance of event, it means that your relative risk is actually more than 1, correct?
Yeah.
Okay. So the odds ratio asks you whether it's the odds ratio will be larger. Okay, let me just do a abbreviate. Odds ratio will be larger than relative risk. True or false?
Is it false?
No. See, I've written out here already. Okay, let me go through again. Now, okay, if relative risk is more than 1, okay, odds ratio will be more than relative risk. If relative risk is less than 1, odds ratio will be less than relative risk. So is this statement true or false?
True.
All right, this statement is true. All right, next question I'm going to ask you is, okay, can relative risk equals to odds ratio?
Yes.
How to have relative risk equals to odds ratio? Look at this. If you have relative risk equals to odds ratio, that means there is no disease or there's no known disease. Okay, so relative can be odds ratio. I would say that in most cases, no. Okay, unless there is either no disease or no disease. That means basically you're just writing a table that is something that looks like that. So one of them, so this is positive, negative, right? One of them have to be 0 to get relative risk equal odds ratio. It doesn't even make sense. Why on earth would you want to do that? Either this is 0 or this is 0 in order to get relative risk equals to odds ratio. Okay, so in most cases, no. Relative risk should never be equal. Relative risk should never be equal to odds ratio. All right. Any other questions?
Sir, may I ask regarding question 5C about the calculation of the appropriate measure of association. In the answer scheme, there's an interpretation mentioned. So, is it correct to say that whenever the question is phrased like based on your answer above, calculate the appropriate measure of association, we must include the interpretation as well, or
not necessary? Not necessary. If we want you to interpret, we'll ask you to explain the measurement. So that's a bit redundant. That's a bit extra.
So it's correct to say that
you can just leave the answer up to here. That's fine.
as long as they don't ask you directly
They don't
for
ask you to interpret. Yes, correct.
oh, oh. So also concerning odds ratio and relative risk, is it true to say that whenever it is a cohort study, then the odds ratio and relative risk will be used, but in the case of case control studies, odds ratio will always be used?
Yes, you can say that. But the difference in the lecture notes, that is one difference in lecture note that you realize I never emphasize in detail. Because, okay, let me go to a lecture itself. The PowerPoint. You realize that on this relative risk odds ratio, yeah. Right. Oh, no, what am I doing? Lecture 3, okay, this. Okay, you realize that on the last slide, basically this is a slide, I never actually go through a lot about it. Okay, because although in cohort study you can use both, in case control study you should only use odds ratio, but it is not entirely wrong to use relative risk for control studies as well. In fact, people tend to put both down at the same time. So it's not entirely wrong. It is not as suitable as odds ratio. That's what it means.
So in other words, it's not the best measure of.
Not the, yeah.
Oh.
For case control study, odds ratio is better than relative risk. Okay, but in cohort study, relative risk is as good as odds ratio.
Oh, yes, sir. So also concerning the concept of relative risk, is it correct to say that it can only be used for cases where the number of subjects that have the disease is small as compared to the number of subjects who do not have the disease?
No. In fact, most people will just calculate relative risk and odds ratio for everything. That is why this is just a very weak no. Most people will just calculate for everything.
Yeah. May I ask, everything meaning like the whole sample or?
Yeah. So every time it's almost like saying, for most papers I've seen, every time I see odds ratio, they will calculate relative risk as well. So it's okay to apply both.
They happen simultaneous.
Yes, correct.
Relative risk and odds.
Yeah. Very often.
So about how relative risk will never be used in cases where the number of subjects which have the disease is small as compared to the number of subjects who do not have the disease in that sense.
No, Sean. You can use relative risk and odds ratio at the same time. Odds ratio is you can treat as odds ratio as a simplification of relative risk. Basically because most subjects do not have the disease. That's why relative odds ratio is an easier calculation. Instead of dividing by the total, you divide by disease and no disease. That's all. So both of them, it can be used at the same time. There's no problem.
Yes, sir. Also, may I ask concerning the question about I believe it was question 7 of tutorial 3 about the phenol something about the so may I ask, is it necessary for us to include this question in the tutorial? Because for question 7 of the tutorial is actually question 8 about the phase 3 clinical clinical trial, but
So this question is not in your tutorial.
no, sir.
Okay, so it doesn't matter. If you know how to calculate, then that's fine. Yeah, I think the tutorial question, some of it is a bit messed up, but you get the idea. That's the main thing. So if I ask you this type of question, you should be able to calculate. The most important part that you need to know is how do you get from the text into a table? That's the first part. If you don't know how to get from a text to a table, then you have no idea how to calculate the second one already. So this have been my emphasis. How do you go from the text to the table? That's why we spend a fair bit of time. Once I know that you can from the text, right, into the 2 times 2 contingency table, I will quite sure that the relative risk or odds ratio, you'll almost get it right.
Yes, sir.
Okay?
Yes, sir.
So this
Thank
is the
you.
first part. Make sure you are able to go from the text to the table. Okay? Without that, you can't do anything, seriously. So far, so good?
Yes, sir.
Okay, then that's all for today. See you next week. You have another half an hour to go and view the lectures.
Thank you, sir.
Okay, have fun. Bye-bye.